Well, it's a shame that the original video, when it was first presented, didn't stay up there because it would have had millions of views
Yeah,
at this point.
it should have done. It was certainly being well looked at quite a lot. A lot of people were probably coming to it for the first time. That's why I made quite a big effort on that presentation.
Yeah, the last time that it was up before it was taken down, it just crossed the 800,000 views. And, and of course, everything from The Awakening was taken down.
Yeah, it was. And the more these lovely people keep commenting, the more people will want to find out what it is they're getting so excited about. The fact that he remembers what I said to Jeremy Clarkson, and that was 25 years ago I did that, 1999. He said it in Clarkson, then he said it at the BIS, so he must have watched them all. That's great. I hope he found them interesting. Still, that's his opinion. He's entitled to it. Doesn't mean to say it's right.
Well, I guess that's the whole thing, is finding the line between reality and fantasy.
Yeah.
Or just like the BIS, imagination to reality. If you talk about it enough, then it becomes real. And unfortunately, I think on this planet, we have very unreal expectations in all walks of life. And I think we need to get back to what is real, what is truthful, and what is viable to keep this planet alive. We're so distracted by our electronic communications and things like that we don't see the planet the same way we should. If we were able to see it and the reality, the fact of the matter is that we need to take care of this planet that we're living on. All of the creations that we have, want, and desire, and our desire for money, capitalism, all kinds of stuff like that, distracts us from what's happening on the planet. Space is the same thing. It triggers the imagination at the same level of going to the movies or any other form of entertainment, going to see a concert, you name it. It distracts you from what's going on. And I'm not saying that having people interested in space travel is a negative thing. It triggers the imagination and makes people want to create new materials and bring the technology up, which can transfer into benefiting people on Earth, on the commercial market, new products and everything else, new materials, that kind of thing. Okay, here's the document that I was looking at, creating the simulated lunar surface. And it was done, University of California, Berkeley is involved in here, and the University of California is involved in this. Basically, it's how they put it together to get the correct color, to stop it from clumping using sand and all kinds of, they're using clay and sand and whatever to get the color down there. So that's all fine and dandy. And then they're using 45-gallon drums and mixing them up in 45-gallon drum batches to do the testing, and then how they spread it out, the different methods they were trying to shoot it out and everything else. In the document, they said their best result was using a hopper, like to make the big surfaces. If you've ever seen them grading large amounts of material and they scoop it up in hoppers and then they can spread it back out again with the hopper, that's what they were using on their stuff. So obviously they were doing this in a large scale. Okay, they're not just testing and tried to do a simulation in a laboratory. They're doing this on a large scale.
Okay, on the article that Scott sent, it was on page 19, or it's page 11 in the article. But what I found was interesting is that, as it says here, it says tests in which soil properties were well controlled have usually been limited to very low impact velocities, and in no study has the penetration at zero impact velocity been determined. And then C, in very few test programs where the soil properties varied over a sufficiently wide range. And then D, the influence of the air pressure at the soil surface has been studied only under limited conditions. And then E, and the influence of the gravitational field has not been studied. Well, why not? You see, when you look at these craters, for example, when they're blowing craters in Arizona, they're putting rods down to measure everything, and then you want to see what the blast radius is going to do, where you see the stuff that's thrown out, the ejected material. But now when they're doing this, you don't see any of that. So I don't quite understand what's going on here with these craters and how they're testing them and the impacts that are going on here. And this goes back to the document that Raza sent when he was on with McToon again, right? They were discussing this soil problem because Raza was going on about that scoop that was on the Surveyor 3 craft, how it was scooping the soil up and placing it into that little box for analysis. And this kind of all ties in with it now, with these soil, all of this soil stuff.
Well, the fact of the matter is they are studying them. I have documents from 2020 and 21 from Hawaii, and they were trying to do simulation with it. And of course, they're using the weight of a vehicle and the thrust of the rocket to create it. And they're using different types of soil underneath to try and simulate what the lunar surface would be like. Of course, they're getting very large blast crater from the landing of a vehicle or firing a rocket at it on the thing. And of course, they're using different mixes of material right up to like full-size gravel, and it's still just blasting it right out of there. But in this particular document, they were more interested in creating what they believe the lunar surface should look like. And they were mixing it together for color and things like that. And there's also another piece in here on how it clumps and bonds and everything else. If you scroll way down in the document, you see photographs of the footprints that they put in on their samples.
Yeah, it's interesting because this was published in 1971, this document. And on page 4, they say they're using estimates of footprints depths from Apollo 11 and Apollo 12. Now, that may well be the case, but they then start talking about pressure up to 5 psi. Presumably that's what they are using in terms of trying to recreate the imprint. Page 4, number 4, but they say that the soil cohesion was measured. It was found that this lunar soil simulant at a water content of about 1.9 to 2% exhibited cohesion values in the range of 0.01 to 0.1 psi. Why are they using water content? There's no water on the moon.
To get the clumping. We see what they're trying to recreate here is what we see in the photographs.
Ah, yes, you're right. Yeah.
So now they're trying to create the soil to match what NASA was using for their images of the soil in those photographs. They're trying to get the color right and everything else. The one thing that they don't have is the very fine cosmic dust that has landed on the soil for billions of years. They do not have any part of that. I was looking through this document for that, how they're going to compensate for that. And it's simply not there. And they deliberately ignore that through any kind of documentation you read on that. You have to go back, 50, 60, 70 years or back into the 1930s where the documents are describing the lunar surface and the amount of very fine cosmic dust that would have accumulated over those billions of years. And they like to put water in all these documents. I don't know why. It's simply not going to be there. You're 10 to the minus 11 or 12, depending on where you are. I don't care. If it's 250 degrees, it's not going to be there, period.
No,
okay.
But, I like what they have here in this document on page 26 in the box. Theory. Based on the understanding of the failure mechanism, bearing capacity theory was modified and additionally theory modified to explain the rolling sphere phenomenon. This led to 3 equations which can be combined to solve for parameters of interest. These equations are as follows, but it's interesting that they have to make all of these equations to figure out how the soil was textured and what it was made out of and how it reacted to different things and footprints and different tracks that were made on it. My goodness gracious, they went to a lot of trouble. Now, my question is, why would they go to all this trouble to do this? Because I think what happened was they were trying to mimic it in their minds, what it would really be like when they actually landed there and started walking on it, had equipment up there, and what the tracks would actually look like in the prints. Yeah. And I think then maybe that's why we see these tracks that are different sometimes, because you have one track that's all black, like very dark, and you have another track that you could barely see. It's almost like they were mixing around these formulas to try to get them to match. But the question is, match what? the photography that they took in 65?
That's what they were doing, matching it after the fact.
Yeah, that's what I think's going on.
Because they already produced it. NASA already produced it to do the photographs in 69, 68, 9, when they were practicing everything else. I think this is just a manner of funding these two universities to give them something to do, to provide funds to them to put these projects together. And of course, the parameters they give them on the testing that they're doing and the samples that they ask them to create, they want them to match what they originally did in the photographs.
That's right. That's a key point, because the original photographs must have been produced somewhere. Obviously not at these two universities.
No.
So they're trying to work out what NASA did earlier in the year, because this is 1971, from Apollo 11 and Apollo 12. So if they use those photographs, which were faked, because we know that you can't use photographic film in a vacuum as hard as they've got on the moon, NASA must have produced them somewhere. Maybe at Cinder Lake, maybe at Cannon Air Force Base, maybe they had simulant there. The reports certainly indicate they did. So all these extended documentation that NASA produces is just another way of trying to demonstrate how much research they have done. But if the research is just going around in circles, and whoever's doing the research now is researching something which was faked earlier, it makes no sense. But as you say, it's a means of getting finance into universities and promoting NASA. And we can all turn around and say, look how much work they've been doing. Look at this pile of documents that they have. Could you fake that? No, it's not faked. It's real. But what they're doing is not real. What they're doing is just duplicating somebody else's work.
Yeah, exactly. If you take that and go back to film again and take it to a university and have them tested in a vacuum chamber to verify that the film actually works in a vacuum, they're going to have some very different results, aren't they?
Yeah, they are.
Because we have done that.
Yeah.
And Bill has demonstrated that the film doesn't actually do that. Here, they're trying to create the soil and verify that that's what the soil looks like on those photographs. So they give them the mixture, they give them the whole thing, they give them the color they want it to be. They want to know how sticky it is, how it clumps, you name it, because that will verify it has to clump to be able to create the footprint.
Yeah, and that's why they put that formula together. I mean, that's quite the complex little formula there.
That's quite the formula in this document to make it clump.
Yeah.
And that verifies this nice clear footprint that we see in the famous photographs. And that's what these guys did after the fact. And because they're a university, then they can say, well, you see, we have a university verified that that's exactly what's in the photographs.
Yes, and we had the University of Patras do our film. Bill Demos did the experiment in the university. So there's seals on this. So that would be interesting for NASA to do this and see what happens. Oh, of course, they're going to use their magic film, so nothing's going to happen. Well, we already know that.
What magic film, he asked, rhetorically.
That's back to the imagination to reality.
Yes, exactly. So come on, all you guys who know these things. Where is this magic film? Let's have a few rolls of it. Can you find it? Do you know what it is? Would you recognize it if you saw it? Come on, guys, let's hear from you.
But it's not just that, though. It's these characters that come out and say, for example, like Brian Lawson, I had to kick him out of that last comment section because he wouldn't stop with this aerial film, UV protection. UV protection didn't come out until the 80s. We've already shown that in the last video. It was 1983, 84 before that came out. So where was it back then? And by the way, he was talking about the Lunar Reconnaissance Orbiter from 1965. He said that that film had that UV protection on it. And if he didn't say it, it was the fellow below him that did. It was in the comment section, and I did show that in the last video that I put up on this. So I don't know what these guys are coming out with this magic coating that's supposedly on this Apollo film, because there's nothing on that Apollo film.
Yeah, there isn't. And if you wanted to use a UV filter on the camera, that would be a much simpler way of doing it. And you can use a UV filter.
Let me ask you a question, Marcus. Didn't they take polarization filters with them?
Yes.
Yeah, they took polarization filters. The problem is with a polarization filter, you need a viewfinder to see what you're doing, because if you rotate it the wrong way, you're going to get nothing.
Yeah, exactly. You've got to get it exactly right to get the actual angle of the filter correct, so it polarizes the light that is coming into the camera. If you don't get it right, you may as well take the filter off. It won't work. But quite why they put that on, it's so obvious. I mean, any photographer would know that. You use a viewfinder with a polarizing filter. It's not rocket science, it's just basic photography, basic optics. Yet another anomaly. Why did I have a polarizing filter?
Yes, so many little details, when you start looking at them, really reveal what was going on, because they would have had discussions on that. That would be in the transcript.
Yeah, they would.
They'd be talking about Houston on what they're doing with these cameras and how they're setting them up. If they were actually there, it would be very important that they take some very good photographs of what they were doing.
Yeah, they should have been.
Houston would be guiding them along. They'd have a light meter to have it, and they'd be talking to, well, I'm facing this way to the sun, and I'm getting this reading. What's your advice on the settings? That would be in the transcript.
Yeah, and they actually did have an exposure meter with them, certainly on
Yes.
Apollo 11, but it was only a spot meter. It measured a very, very small angle of light. It's a sensible thing to have if you want to get the exposure correct, but there's no mention of it ever being used.
There's no
Nothing.
image of them using anything like that.
No, they didn't.
You don't find it anywhere on their body.
No,
You would think it would be sitting on a tether that they could just pull it up.
of course they would.
Yeah. Well, it's not on their suit anywhere. None of
Oh.
the photographs.
If they were using it, it would be obvious they were using it, because it's a Minolta spot meter. It's quite easy to identify it, but it's never seen anywhere, not in any of the photographs, not in any of the films. I don't even know where it was stored. The thing about so big, it's not very large.
There's images on the journal side of it. It is there, and I have looked for it. I've looked to see where it was stored and everything else with the camera equipment. They put a pocket for their sunglasses, but they didn't have a pocket for their spotometer.
Oh dear, oh dear. No matter how hard NASA tried to get the story to stack up, most of the time they succeeded, but occasionally they didn't get it right. They got the wrong story. And we're now being able to identify the story that's gone wrong. And this is one of them. They had an exposure meter and they never used it. Why would that be?
Then you've got people out there dropping every kind of weight there is. You had the payload specialist that dropped everything, and they counted every stitch in the suit to reduce the weight. So if they had this piece of equipment, they didn't use it, then the specialist would have said, if you're not going to use it, you don't need to take it.
Quite right. Yeah. Drop it. Get rid of it. Not wanted on voyage. You know, the famous thing when people went on posh cruises, port out, starboard home. That's where posh comes from.
This is quite interesting, the math that these guys put into this, you know, and I mean, why would you need this to be exact, 100%? Why would you need it that accurate when you're just doing simulations?
Exactly.
And not only that, but the graphs, the charts that go with it, they're just incredibly detailed.
Yeah. They get paid more money for that. You put graphs in, formulas in.
I mean, they go on, the state of soil compaction of lunar soil may vary, the cohesion may vary, the friction angle may vary, the measured track width within the basis of the range of theta or beta was not representative of the crest-to-crest track. I mean, this is crazy stuff here that these guys are going over. And again, there's another 2 pages of math.
There's a lot of formulas there.
And I like what they say on page 28 here. They're speaking about these general bearing capacity factors for an infinitely long footing on a slope as determined by Meyerhoff, 1951. 1951?
Yeah.
I don't remember them sending any photography equipment in a satellite or anything in 1951. Do you?
No, they didn't have anything going off the ground at that time. If you want to take all that mathematics, if you want to see how dirt falls, how high you can stack it up on a slope for its cohesion and friction, you just simply need to lift the box on a dump truck and let it dump out, and it will give you that grade. You don't need all that mathematics to do it.
But maybe that's why we see that one crater that looks like the dump truck is just backed up and then kept on going. And you see all those lines like the dump truck has come.
That's how they know the gradient angle. These guys are verifying the soil, the type of soil it is, to the gradient angles of the craters themselves.
And then another thing this is talking about is the borehole probes.
That's when they're digging down in there, taking core samples.
Oh yeah, the borehole tensile strength of rocks. And again, we're looking at another whack of formulas again.
It's a guess, basically, because it's not a real borehole, whatever they say.
Yeah, and then after that, they dropped this instrument down it.
Well, the borehole they just made at the university.
It's called a borehole jack on page 36 in the box. And then on page 37 in the box, that's where it gets attached to all this instrumentation.
Oh, that's right. Yeah.
So these guys, I mean, they really went to a large extent. And then on page 38, that's where we get the actual graphs that they took from that instrumentation, the jack pressure. This is crazy what they went through just to mimic this soil.
Well, it's amazing what you can charge for a report like this. And you can say, look, we had to use all this equipment. You had to use all these different gauges. Amazing amount of money they would get for it.
Oh, yeah. And then you go to the studies of fluid conductivity of lunar soil surface materials, and again, you have a whole whack of paragraphs here. You're looking at the transition regime of flows. And then we're talking about the Knudsen number based on pore size, is order of unity. It's really something here. The design, the rock specimens, the apparatus used. It's just crazy stuff here.
It is. And it's all done at university, not done on the moon. The only thing from the moon is the alleged photographs of the moon, which we know weren't taken there.
Yeah, so it is really crazy what they've done here. Upper bound, lower bound layers, variation time constant with lengths of radius ratio, scale time constant, page 43. This is a lot of trouble to go through just to make soil, just to make this theoretical regolith, How much did Jarrah pay? Can you remember what he paid for that?
It's about $30 a kilo. I think it's somewhere around there. Wasn't that much, and he got quite a lot, and he probably got about 10 kilos.
Jarrah's experiment with the boot print when he purchased that soil simulant, look at the print that he got in there. I mean, it was good and solid.
Oh, yeah.
And look at the ones the Mythbusters got. That's quite a big difference, I think.
I think, yeah, there was. In fact, I thought the Mythbusters footprint was not very impressive. It certainly didn't represent the picture they were trying to recreate. Interesting that no other Apollo mission, so far as I know, had similar boot prints. No photographs.
Oh, something, you're right. Because they only took the boot prints of Neil Armstrong's feet. They got close-ups of it.
Yeah, it's the close-up, because that means you can identify quite a lot of information about it. But every other mission, they showed prints, but in the distance, you couldn't actually see very much of them.
No, and then, that's another strange thing. Here we are on page 9 in the box, and this is really something. The gradient of the lunar soil simulant used in previous studies was LSS number 1, and that was in 1970. Now, this was modified to more closely match the gradient of examples returned from Apollo 11 and 12 missions by decreasing the percentage of material coarser than 1 millimeter, which is shown in figure 1. The behavior of the lunar soil simulant was investigated, and the following conclusions can be made. 1, the lunar soil simulant number 2 appears to be a good match for the actual lunar soil in terms of gradation, penetration, resistance, and other physical properties. The conclusion report and the final report of January 1970 regarding the sensitivity of lunar soil properties to avoid ratio is reinforced by studies on the sample number 2. These studies indicate that most soil properties of interest can be predicted from knowledge of the void ratio. And number 3, strength, stress strain, and one-dimensional compression parameters of a lunar soil simulant have all been related to a void ratio in both equations and graph forms. So then they go on to say the idealized, oh, forget that. Then they just go on about the graphs here. More graphs again on the gradient of this simulation. So, I mean, yeah, this is really something. But I noticed this is 1970. This is when they started to make this soil, they say, more accurately. When they actually, according to this document, had the samples returned from Apollo 11 and 12.
Yeah, that's all they had to work with. The samples allegedly returned from 11 and 12 and the photographs. They were working from the photographs. Whether they were using the samples that were brought back on these aluminium boxes, I don't know. Because if they weren't on the moon in the first place, they wouldn't have been able to get anything other than simulant samples.
But then on Surveyor 3, they scooped the soil up, put it in that little box, and then did their little tests on it. And the data that they got back, I wonder if they could have used some of that to mix the soil up on the pre-flight before they went.
I don't think anything from Surveyor came back to Earth.
They did all the tests right there. They had a laboratory, so they say, on board of that craft, and then they did the tests there. I mean, they had the cameras looking down at the surface. So maybe they could have deduced something out of that.
Yeah.
It's hard to say. Did the Russians?
Yes, they did. Only about 300 grams. 300 grams is about 10, 12 ounces.
But the Russians wouldn't have shared that knowledge with the Americans at that time, would they? Spies, maybe?
No, the Russians tried to persuade America to share their samples so that they could be compared. And Russia offered America some of their sample so that they could compare it as well. And America refused. There was a big debate about it. It went on for about 18 months before America would agree to accept some Russian samples. It's almost as if they knew if they sent any to Russia, they would identify them as being fraud because they weren't real lunar soil. The lunar soil was returned by Russia, a couple of 100 grams of it, not the 842 pounds of rocks Apollo alleged to have returned. It's almost like they went into overkill on it and then refused to compare them.
It's unbelievable that Russia had the technology back when they claimed to have returned the samples. The machines would have to be completely autonomous.
Okay, just one last little paragraph here on page 12 on number 4. It says, cohesion was measured. It was found that the lunar soil simulant at a water content of about 1.9 to 2% exhibited cohesion values in the range of 0.01 to 0.1 psi. This range is similar to that observed for lunar soil. Yeah. So now they're saying that lunar soil has water in it. This is what I'm getting from it.
Yeah, that's what it says. Well, they say it's the lunar soil simulant. There's a water content of about 1.9 to 2%. But that couldn't possibly be a simulant because we know there is no water on the moon. The high temperature is 250 Fahrenheit. The lack of pressure, the hard vacuum, water would not exist.
No, and then they go on to say that these factors were used to relate footprint depth to avoid ratio as shown in figure 4. So now we're going back to these footprints of Neil Armstrong that are zoomed up. Yeah. Because they're claiming that there's a given range of 0.1 to 0.5 inches for most values with an average value of about 1/4 of an inch. So again, now we're talking about footprint depth.
That's what this document was to verify the photographs that NASA exhibits.
Right. If they had to put 1.9 to 2% water in there, then that means that the lunar soil would have that in there. So now we're going back to that show Smoke and Mirrors, how he was saying that they were mixing a little bit of water and oil in there to make the soil stick. And then when we go back to Apollo 17, what do we see? We see all this dirt stuck literally like oil all over the back of that rover's hub.
Oh, yeah, but that oil's coming off the rover. It's sticking to them. It's sticking to everything else. But even if they took a core sample on the lunar surface, as soon as they pull the core sample up, if there was any moisture in it at depth, as soon as they bring it up, it's gone.
Yeah, of course it is. The vacuum would get rid of it instantly.
Yeah.
It's unbelievable. Unbelievable. Unbelievable.